Subscribe to our channel and hit the bell icon so that you don't miss any updates from technical beings.
Hey guys, welcome to another video. Today we will see the difference between NAS and SAN. So what is the difference between NAS and SAN? Both network attached storage NAS and storage area network SAN were developed to solve the problem of making stored data available to a lot of users at once. Each of them provides dedicated storage for a group of users, but they couldn't be more different in their approach to achieving their mission. A NAS is a single storage device that serves files over Ethernet. This sentence you have to keep in mind, that a NAS is a single storage device that serves files over Ethernet and is relatively inexpensive as easy to set up. Relatively inexpensive as when it is compared with SAN, because the setup of SAN is a bit expensive as compared to NAS. While a SAN is a tightly coupled network of multiple devices that work with block-based data and is more expensive and complex to set up and manage. From a user's perspective, the biggest difference between NAS and SAN is that NAS device looks like volumes on a file server and use protocols like NFS and SMB CIFS, while SAN connected disk appears to the user as local drives. You will get an overview of the differences between NAS and SAN here. If you look at this picture, looking at the SAN, the clients are attached to Ethernet switch, and then Ethernet switch is attached to the server, and the fiber channel comes into picture, which relatively helps in a better performance, but the fiber channel which is coming into the picture is more expensive when it comes to NAS. And coming to NAS, the clients are connected to Ethernet switch and then network attached storage and then server. So this fiber channel in SAN is increasing the expenses. This is why it is considered as expensive, and NAS which don't have fiber channel, but there is a drawback that the performance is slow and there is sometime latency faced in NAS. So as compared to the performance, SAN works better when it comes to performance. So this is the picture showing how the cabling is done. This is just a picture for reference where the SAN and NAS, how the cabling is done, the heavy cabling. Basic definition: what is NAS? A NAS is a computer connected to network that provides file-based data storage services. This is particularly highlighted just to make sure that you remember that NAS is a file-based data storage service to other devices on the network. The primary strength of NAS is how simple it is to set up and deploy. NAS volumes appear to the user as network mounted volume. So this is how it appears to the user. It appears as network mounted volumes. The files to be served are typically contained on one or more storage drives, often arranged into logical, redundant storage containers or RAID. The device itself is a network node, much like computers and other TCP/IP devices, all of which maintain their own IP address and can effectively communicate with other network devices. Although a NAS is usually not designed to be a general purpose server, NAS vendors and third parties are increasingly offering other software to provide server-like functionality on a NAS. NAS devices offer an easy way for multiple users in diverse locations to access data, which is valuable when users are collaborating on projects or sharing information. NAS provides good access controls and security to support collaboration, while also enabling someone who is not an IT professional to administer and manage access to the data. NAS also offers good fundamental data security through the use of redundant data structures, often the data structure often called as RAID, and automatic backup services to local devices and the cloud. So looking at what are the benefits of NAS, a NAS is frequently the next step up for a home office or small business that is using DAS. DAS is nothing but direct attached storage. The move up to NAS results from the desire to share files locally and remotely. Having files available 24/7, data redundancy, the ability to replace and upgrade hard drives in the system, and the availability of other services such as automatic backup. Here we will look on some of the summary of NAS benefits. It is relatively inexpensive, 24/7 and remote data availability, good expandability, redundant storage architecture, automatic backups to other devices and cloud, and last but not the least, flexibility. In this picture you can see that a storage device is there in between and it is surrounded by the network attached storage and the clients are connected to that network. This is how a NAS looks. This NAS with 8 drives base for 3.5-inch disk drive. This is just for your reference in case you might be wondering how does a NAS looks. So this is how it looks. So what are the limitations of NAS? The weakness of a NAS are related to scale and performance, which I have already told you earlier. As more users need access, the server might not be able to keep up and could require the addition of more server horsepower. The other weakness is related to the nature of Ethernet itself. By design, Ethernet transfer data from one place to another via packets, dividing the source into a number of segments and sending them along to their destination. Any of those packets could be delayed or sent out of order and might not be available to the user until all the packets arrive and are put back in order. Any latency, that is slow or retry connection, is usually not noticed by users for small files, but can be a major problem in demanding environments such as video production, where files are extremely large and latency of more than a few milliseconds can disrupt production steps such as rendering. Coming to the next one, that is SAN. The basic definition is a SAN is a way to provide users shared access to consolidated block level data storage. Specifically highlighted just to make sure that you remember that SAN is a block level data storage, even allowing multiple clients to access files at the same time with very high performance. A SAN enhances the accessibility of storage devices such as disk arrays and tape libraries by making them appear to users as if they were external hard drives on their local system. By providing a separate storage based network for block data access over high speed fiber channel and avoiding the limitations of TCP/IP protocols and local area network congestion, a SAN provides the highest access speed available for media and mission critical stored data. So this is what we have already discussed earlier, that SAN, when it comes to performance, it is extremely good and it is better than NAS. So this is how it looks. The clients are attached to the fiber channel and the fiber channel is attached to the storage devices, and this is how it works. What are the benefits of SAN? Because it's considerably more complex and expensive than NAS, SAN is typically used by large corporations and requires administration by an IT staff. For some applications such as video editing, it is especially desirable due to its high speed and low latency. Video editing requires fair and prioritized bandwidth usage across the network, which is an advantage of SAN. A primary strength of a SAN is that all of the file access negotiation happens over Ethernet, while the files are served via extremely high speed fiber channel, which translate to a very snappy performance on the client workstation, even for very large files. For this reason, SAN is widely used today in collaborative video editing environments. Summary of SAN benefits: it is extremely fast data access, dedicated network for storage relieves stress on LAN, highly expandable, OS level is block level access to files, high quality of service for demanding applications such as video editing. Coming to the limitations of SAN, the challenge of SAN can be summed up in the cost and administration requirements. Having to dedicate and maintain both a separate Ethernet network for metadata, files requests, and implement a fiber channel network can be considerable investment. So as I have told you earlier, this could be a considerable investment, a huge investment. So most of this big organizations are choosing SAN, and NAS is for the middle-sized organization. So that being said, SAN are really the only way to provide very fast data access for a large number of users that also can scale to supporting hundreds of users at the same time. NAS and SAN convergence. The benefits of SAN are motivating. Some vendors offer SAN-like products at lower cost by avoiding the high expense of fiber channel networking. This has resulted in a partial convergence of NAS and SAN approaches to network storage at a lower cost than purely SAN. One example is fiber channel over Ethernet, which supports block level transfer over standard LAN at speed of 10 GB per second plus. For smaller deployment, iSCSI is even less expensive, allowing SCSI commands to be sent inside of IP packets on a LAN. Both of these approaches avoid expensive fiber channel completely, resulting in slower but less expensive ways to get the block level access and other benefits of a SAN. So we will just quickly look into the differences between NAS and SAN. NAS typically used in homes and small to medium sized business. SAN typically used in professional and enterprise environments. NAS less expensive, SAN more expensive. NAS is easier to manage, SAN requires more administration. NAS data accessed as if it were a network attached drive. SAN server access data as if it were a local hard drive blocks. NAS speed dependent on local TCP IP, usually Ethernet network, typically 100 megabits to 1 gigabit per second. Generally slower throughput and higher latency due to slower file system layer. SAN high speed using fiber channel, 2 gigabits to 128 gigabits per second. Some SANs use iSCSI as a less expensive but slower alternative to fiber channel. NAS input-output protocols are NFS, SMB, CIFS, HTTP, and SAN works with virtualization. NAS requires no architectural changes, SAN requires architectural changes. In NAS, entry-level system often have a single point of failure, that is example is power supply. In SAN, fault-tolerant network with redundant functionality. Susceptible to network bottlenecks, So this is same for both. File backups and snapshot, economical and schedulable. Block backups and mirror require more storage. So that brings us to the end of this video. Thanks for watching. And if you liked this video, do not forget to click the thumbs up button, subscribe to the channel and hit the bell icon so that you don't miss any new updates. Because your support will motivate me to make more videos, and I'll be coming up with these type of videos very often. So stay tuned. Alright then, see you in the next video. Till then, take care. Bye bye.